Hello, welcome to video 5.4 of Beginning App and 2D Game Design. Today we're going to be, or for this time at least, we're going to be covering a little bit about the player control of our shooter game, as well as I'm going to go a little bit more into the design. I'm going to actually show you some stuff from the Hulk design document because I had promised to show you that before, and so that's kind of a hodgepodge issue. But I'm going to just throw that into this discussion, and let's go ahead and get started right away. So let's pull up our project again. I actually still have the SUD mini project pulled up from before. I just showed you guys how to grade those, so I'm going to close that out, and I'm going to go into my shooter project. And again, here's my shooter project. So I've got the, if you remember from last time, basically we hit debug and we just see a ship on the screen. This is the ship that Microsoft has provided us, and it's just drawing it out to the screen. So let's wait for that. I just hit debug here. Make sure you got at least this far, and there is our ship. So first thing we want to do is basically we're going to now control the player input. So you notice that the update loop has nothing in it right now, absolutely nothing. So that's kind of a problem. Remember, this was our design flow chart from before. Check for input is kind of a big item on here, and then be able to get the player to move, and the ship update velocity to happen, and the position change to happen. So that's kind of a biggie. We figured we'd do this first, do the input first, and actually move the ship. Then we'll do the firing of the bullet, then we'll do the collision, and finally the drawing. We're actually doing the drawing, but we'll be drawing some additional things like enemies and bullets in a little bit. And then eventually we'll get to our menu system. But anyway, so for now, here's our initialize function, here's our update function. Doesn't have anything in it. I'm going to want to put some stuff in it. But the first thing I want to do is note that there's going to be a bunch of different types of input that's possible. And I'm just going to chart that out for you. Basically, if XNA supports multiple platforms, so if you're on an Xbox 360 with your XNA games, this is going to be a controller. If you're on Windows PC, this is going to be your keyboard and mouse. If you're on a Windows phone, it's going to be a touch device. Controller, keyboard, and mouse are already all built in, but we do want to add support for the phone just in case. So I'm going to add using Microsoft.xna.framework.input.touch in here, and now I will get input touch control. So next up, we're going to go down and take a look at our player. Our player needs some information inside of game to make it work. Basically, the player is kind of just this object that has texture, position, health, etc. But something else, just like in the SUD mini project where basically we detected the keyboard input and would do things based on that, we're going to do the same thing here. So it's actually in game1.cs that we want to make these changes. So if I open up game1.cs, I see that we've got a player defined already. I'm going to go ahead and add some lines to the instance variables section of the game, because these are basically going to keep track of our keyboard states, our previous keyboard state, as well as our gamepad states, and what the player's current move speed is based on that. So I'm going ahead and adding keyboard state, current keyboard state, previous keyboard state, and then the gamepad state, current gamepad state, previous gamepad state. We're going to essentially make this so that it works with an Xbox 360 controller as well. And then we've got basically the player move speed that will be updated from the game1.cs as well. You might notice here player move speed is actually not being initialized yet. We're going to take care of that in the initialization function where we actually set a move speed. So we're going to look down for initialize, and here we see it is where we actually created the player, and I'm going to write player move speed equals 8.0 f F stands for float. That's how you know that ends as a float, and 8.0 will instantly become a float, and that will be the move speed for the player. And I'm getting an error message. Any guesses why? That is right. If you guessed that it is because I included the touch stuff in player.cs but not in game1.cs, you are absolutely correct. So I need to go ahead and add this as well in the game, and then I should be fine and ready to go. So I'm adding that there, and voila, I don't have any error message anymore. So now the touch device can get updated inside of our initialization loop like we had. So enable gestures is enabled. That's going to enable the free drag gesture. Now, this is setting the player move speed. What we want is the update loop is supposed to basically take into account the movement of the keys on the keyboard. As you move that keyboard around, basically you want to be able to have the ship go up and down, left and right, etc. And in order to do that, we would normally do that in the update loop, but the update loop, as you could probably tell, is going to get kind of cluttered with all kinds of stuff. So it would be better in this case to do what we call encapsulation and put it inside of its own method. So I'm going to go ahead and make a update method just for the player. And this is what it'll look like when it's done. We basically say update player. I'm going to go ahead and add a summary, so I've got my doc comments here. Update player will be called from update as often as update is called. It will update the position of the player given current gamepad state and current keyboard state. So if you look down below, what we have here is basically we're going to get the thumbstick controls. Player.position X is going to change based on whatever the current gamepad state left is times the move speed, and the right and the left.y is times the player move speed. So that's going to use the thumbstick to move around on the screen. The keyboard is going to be coded up as follows. Basically, if the key left is down and or the left D-pad is pressed on the gamepad, then we're going to count that as moving back in the X by a certain amount of move speed. So we're going to say by move speed. If it's right, or if the D-pad.right is down, then we're going to add in the X, so we're going to go forward. If the key press up is going on, we're going to go up in the Y, which is actually down, which is actually a negative, because remember, if you look at any given window, 0, 0 is up here, 100, 0, or I'm sorry, 0, 100 is down here, where this is the Y. So as we decrease in Y, we go up. So we're going to do a minus equals on player move speed and actually move up. If we go down, again, we go down in the Y, and that's how we do it there. And again, the X goes over here. So when you've got your X and Y over on this side, as you're pressing the key down right, you're moving over and over, closer and closer to X equals the size of the window screen. So that's about it for the update player. We also do need to make sure the player doesn't move out of bounds, so there's a clever way of doing that, which is a little bit clever than what I did before when I had the ball moving out of bounds. But basically here I'm going to use something called a math helper, and I'm going to clamp the player's position to the X and 0, and what the clamp is going to do is basically give it a maximum value equal to the width of the viewport screen minus the width of the player. And then the Y is going to be clamped to the to the player position.y is going to get clamped to the minimum 0 and the maximum of the height of the viewport minus the player height, so that it essentially clamps it so it doesn't go out of bounds. So in other words, if it's below this minimum, it's going to clamp it to that minimum. If it's above this maximum, it's going to clamp it to that maximum. So it's going to hover right on the edge of the viewport.width minus the player width in the X and the viewport height minus the player height in the Y. And that's what's going on there. Now that's not going to be enough to do anything because, well, I'll let you tell me, why do you think that is doing nothing yet? If I run this, nothing's going to happen. I'm just going to see my ship just sort of sitting there, sort of doing nothing. And the question is why? Well, because I've got this update player already, right? But oops, it's never being used. That's right, no one is actually calling update player, so we actually need to do that from inside of the update, which runs every tick, and on the game time intervals is when it's actually running. So inside of this section where it says to do update, add your update logic here, we want to actually update it. So we're going to do so as such. First off, we're going to record the previous gamepad state and the previous keyboard state. We're going to do that essentially so that we can detect if the previous states were the same as the current states, and that's going to allow us to determine single key button presses, one versus the other, for later on. We're also going to read the current state of the keyboard and gamepad and store it inside of current keyboard state and current gamepad state. And so we just read that saying keyboard.getState, gamepad.getState, player index 1, because there can be more than one gamepad. So this is taking the player index .1, .1, 2, 3, and 4. These are all enumerations on side of the player index. That is the player index actually passes back an enum for the game controller that's associated with that particular player. And then after that, we're going to call update player finally with game time. This is the one that actually goes into update player with the game time and has the current gamepad state and the current keyboard state, which was set prior in the update. So I'm going to go ahead and run that. I don't have a 360 controller, but I do have a keyboard. Well, I mean, I have one, but I don't have one connected to the PC right now. But I do have keyboard, and I'm moving this around with the arrow keys, kind of moving a ship back and forth, and eventually you can kind of envision how this will be firing, and etc., etc. So that is it for the shooter project, at least for this week. Next week, we're going to be doing some animation of the player. We'll also be getting into some more advanced things like the bullets that come out of the ship towards the enemies. We need to be able to code those up. And I just want to very quickly run through the rest of what we're doing with this shooter, just so you guys kind of get a idea for where we're going next. Let me just bring up D2L really. So I'll just bring up D2L here, go to the app LOOC, the good old app LOOC, and go to my updated schedule, which was just updated this morning. This shows basically that we will be doing the player again. Next week we'll be doing animations for the player, specifically for the shooter project. We will also be talking about vectors and various ship assets, including the bullets and that kind of thing, and we'll be basically finishing up the shooter project, and that should be good to go. Now, there is going to be another video with an introduction to the first game project, the first big game project that is, and that will be coming out shortly, so you guys can check that out. There will also be an optional assignment due this week, like there usually is, and you can look forward to that as well. Also, before I close, I did promise to show you some additional game design documentation, so I'm going to go ahead and do that. But again, remember that basically our goal here is to complete the shooter by next week and use that as a baseline for going into your main game project. So without further ado, let's bring up the so here we are with the core game design of Incredible Hulk Ultimate Destruction. I got permission to use this for academic purposes only. Please do not duplicate or disseminate this throughout the internet. This is just special for the LOOC class. So this was Incredible Hulk Ultimate Destruction, the game that came out for GameCube, PlayStation, and the original generation Xbox. Was released. The game design document was released in May 13th of 2004. And we talk about sort of the original vision of the Hulk game design. So this is sort of using the core game design doc templates that I had already sent to you. As you can see by the table of contents, we've got the Hulk game design, which includes the analysis, the concept, the goals, what it is and what it isn't, the game genre, the brand market analysis, as well as the missions, the story, the transformation to the Hulk, collectibles. As I said, it's also what it is not about. Banner is not playable, for example. It didn't fit in the game design. So the Hulk game design, here we start with the quote, "You're like a bomb, and when you go off buildings, catch fire, people die," all that's you, Bruce Banner, you're a big green time bomb ticking. So the idea was the Incredible Hulk on the Richter scale, smash everything, all the power of the Hulk, gameplay depth and variety, intense ticking time bomb story, and rampaging in the real world. The game analysis is that it's an action-adventure game based on the Marvel comic property, The Incredible Hulk. We have some game goals that we set up for consumer expectations, delivering the ultimate experience, positioning the franchise, and just living out the rage of the Hulk. We get into what it isn't. This is important in a design document to talk about it, what it isn't. It's not about small, intimate places. It's about big places, broad strokes. It's not about trite events. Hulk can do things like slam a bunch of soldiers through a storefront, wreck entire express trains, grab a hold of a helicopter gunships and pummel them into the flaming wreck spiraling down towards the ground, kick a Toyota 4Runner across the street as if it was a cardboard box. Hulk doesn't think, he doesn't reason, he doesn't show significant communication skills, he doesn't stop fiendish bank robberies, he doesn't save sobbing children from burning buildings, he doesn't rescue meowing kittens from trees, he does not strategize beyond the short term. It's not a Marvel Universe adventure game. It is part of the continuum of Marvel, but it is not going to contradict Marvel, but we're not going to be basically featuring Spider-Man or other Marvel superheroes. It's basically Hulk Ultimates is what was inspired this game. Or Marvel Ultimates, I should say, is what inspired this game. There's a competitive analysis for competitive franchises. The gameplay direction that we're going, basically gameplay direction is based around the best possible Hulk experience, taking a sandbox approach to the environments. Jump anywhere, climb anywhere, do anything was kind of key to the mechanics. Here's a list of the features we're going to be able to weaponize. We're going to have a fully interactive world, jump anywhere, climb anything, learn to move bigger and badder bosses throughout the game. Here's some design terminology that'll come up later for missions and chapters and that kind of thing. And then we get into the mission breakdowns. So primary mission objectives, mission acquisition, how you initiate a new mission, how you unlock missions. So that's just kind of a flavor of, a professional level game design document. This is the core design doc, which is only about 40 pages long. And you can see some of the playable characters there and some of the missions. The front end was designed here, the save data was designed, various difficulty levels. Here's a flow chart similar to what we just saw when we were doing the shooter actually, um, and so on and so forth. So that is the game design document. As I said, I wanted to get more into game design documentation. Also, game objectives are very easy to talk about in terms of the Hulk, just something that we were due to talk about today. When you think of the Hulk, you think of just raw power, and so the objectives were to basically have a third generation PS2 game that leveraged all the abilities that the Hulk fans expect, deliver a complete Hulk experience, create a benchmark super title hero that defines the Hulk experience, gameplay on a scale that you cannot get anywhere else. We want it to be a defining experience for the power of the Hulk and really capture the rage of what it is like to be the Hulk. So those are all sort of the objectives of the game, the goals of the game. Now the objectives themselves to the player, he's never going to feel any of that. He's instead going to feel the objectives of what he's doing moment to moment, and those all come in the form of mission objectives, which are down here. Again, this is just the 40-page core game design doc. The full game design doc, the game design Bible is what some people call it, is about 320 pages, and I have excerpts of that I'm going to show as well. So this is sort of showing some of the missions, primary mission objectives. You get missions when you're in your safe haven. There's also secondary missions during free roam gameplays. For example, perform 5 weaponization moves for a bonus, or perform 10 grapple finishers, or sustain critical mass for 60 seconds for a bonus. And you acquire missions throughout the game as well. You obtain objectives through mission briefings that show you what you're through rendered cutscenes as well as runtime cutscenes. You see what your mission objectives are. So that's basic core game design doc for a production level game that was created now some years ago, but a very popular one. So hopefully that's something that is useful to you as you understand, make your way about this industry and get used to things. So the next thing I wanted to show was a technical design doc. This is from a game we did at Frozen Codebase right here in Green Bay. The last one I showed you, of course, I worked on that out in Vancouver, British Columbia. Fresco Beach is also called Sandy Beach. It's a WiiWare title that was put out by Konami for the Wii a number of years ago, back in 2008. This shows a little bit of a different design doc. This is a technical design doc, so it had technical goals, basically to feel like, in this case, it was a sandcastle building game, and it had all kinds of tools that you would basically be able to use to get your, you basically place your blocks in the world. You would go to your toolbox. You would be able to shave off parts of the sand and then place them on the top of the other, and that essentially made for a sandbox building game. And so we had goals on this that we wanted it to feel like you're building a sandcastle, but also this gets into the technology of it. So we used the Vicious Game Engine for this. This is the part where if you were creating a technical game design doc for example, an XNA game, you would talk about the XNA tool set that you're using. Maybe some of the games that XNA launched with. These are some of the games that the Vicious Codebase launched with. We also used Fmod for our sound system, and we talk about some of the specific audio implementation notes for Fmod inside of here. Another technical note is that we used Live Move Pro, which is an advanced technical solution towards matching hand gestures using the Wiimotes, and this describes the Live Move Pro in great detail, where basically there is the people that down here that's showing that are moving the Wiimotes around in certain motions, and it uses AI pattern recognition to have a motion recognizer that then at runtime recognizes and understands the movements for the players that they're making. So we then go about and explain the game structure and how the game is going to be broken out into a grid, and how you're going to use the nunchuck to move the camera around, as well as the Wiimote to grab the bucket and place it on the sand. When I first pitched this game, I was actually a producer on this title, not a programmer. like I was on the Hulk title. When I first pitched this game, my programmers actually thought I was a little bit crazy. They were like, well, how are we going to actually build a sandcastle type game? Sounds a little too complex for the Vicious game engine. But we ended up making it simple enough that it could be launched in WiiWare, and this technical design doc was a big part of it. I had to create this document to convince them that we could do it. One of the things I suggested at the time was that we would basically take and have templates that you could choose from. So this is choosing from various templates of blocks that can be placed, and we would go through all these, place one, and then go on to the next. And through these simple actions, you would be able to create a sandcastle. We also introduced, because they wanted it to be like you're building a sandcastle, we introduced the notion of holding the B button here to draw on specific patterns on sandcastle walls. Here was an early in-game screenshot that we took of an early pre-production prototype for Fresco Beach, which ended up becoming Sandy Beach. This shows the various piece configurations that we would have. Eventually we would actually end up having more of these. And this shows a castle built out with all of those pieces. Controller diagrams are very important for TDDs as well as GDDs. This one is showing the entity class hierarchy of the Vicious game engine with its variables, with its camera variables. This is the third-person follow entity 3D camera, and this was included just to basically prove that we had thought of everything in terms of how the camera would feel. The architecture itself was documented of the Vicious game engine. So the Vicious game engine has multiple tiers, and we had to document this. It has the core tier, which introduces memory management features, file I/O operations, and thread support. Then it has the math tier for all the mathematical functions, as well as a physics layer and a networking layer. We also talk a little bit about the point-and-click interface that was the scripting engine of Vicious, and how to assign variables, what if statements are like, what switch statements are like, while loops, returns, etc. We talk about how we're going to get the networking model to work over WiiWare, which was sort of a difficult thing. We ended up actually cutting that due to scope, but we did propose certain network events that would happen when you would join various games, and we were envisioning that people would be playing and making sandcastles together, and that they'd be able to connect via a lobby. Here's some actual pseudocode for initializing players being assigned to a certain host. Here we talk about Nintendo Wi-Fi API connection that we would have had to use if we did end up making this a Wi-Fi enabled game. So that is that's a TDD, and there's basically 9 steps you got to take in writing a TDD. To create a technical design doc, here's the main 9 things that you need to do. Sorry, I had copied this from somewhere else, so we had chapter 6 in there, but now we're just going to say, okay, so to create a technical design doc, we need to describe the roles and responsibilities of the programming team, define the architecture for the game design, identify the tools being used, list the risk and contingencies, describe any AI or physics subsystems, list the considerations of the target hardware platform, describe multiplayer and online systems, describe the graphics subsystem, and prepare for a technical design review. So the only one of these that we really didn't capture was the roles and responsibilities of the programming team. We ended up having that in a separate document. Also preparing for the technical review, which is mentioned as number 9 on my hit list of technical design doc things that you must cover. Wasn't needed either, so we didn't do that. The technical design doc itself served essentially as our review, and the publisher was fine as long as we had this completed. So that's our technical design doc for Fresco Beach. You might be at some point asked to create a technical design doc. In fact, I know you will be, so you can use that as sort of a template and refer back to this video. See you next time. Next time you hear from me will be on a video where I describe the project.